satellite data for journalists with a specific focus on how you can use satellite data for reporting on wildfires. So my name is Julia Wagemann, and I will run this workshop together with Sabrina Sito. And we've been working in the geospatial and satellite community for the past 10 years. But we realized, and we worked a lot in the interface between data organizations who make this satellite data available and users. And we saw a growing demand in using the satellite data, but at the same time, there's also a growing complexity understanding the landscape of satellite data, which leads to an unfulfilled potential of actually using this valuable data for a lot of aspects. And one area where the satellite data it can be and is useful is in reporting and in journalism. And that's why we started the idea to run dedicated workshops specifically for journalists with the aim to help you to navigate through the landscape of satellite data and also to give you some hints on how you can access the data. And yeah, I would say we start because we have quite a full program and quite a few things we want to cover. So what is today's workshop about? As I already said, we really want to increase the use of satellite data in different domains. And so today the workshop focusing on giving you an overview of what satellite data you can use specifically for wildfire reporting. We will describe you the different types of satellite data that can be used along the entire fire life cycle. So before a wildfire, during wildfires, and then also after wildfires occurred. And we will summarize different web portals that offer easy access to the specific datasets we introduce you today. And this is also a caveat for today's workshop that basically the landscape of satellite data is really fast. There is a lot of satellites and a lot of data available. And today we only have 1 hour. So we really only focus on a very small subset of the wider landscape. So we focus only on selected data sets for wildfire monitoring that are available in web visualization portals so that you can access where and you don't need any coding or any advanced data analysis skills. But of course, the more technical skills or the more data handling and data analysis skills you have, the more options you have then in the number of satellite data sets that are available for you, and also the options to modify and tailor the data sets to your specific needs. So today we have specifically 5 parts. So we start with an introduction and the short icebreaker, and then we have 3 main parts. The first part is that gives you a really crisp and short introduction to what remote sensing is and how satellites actually acquire data, or what satellite can observe. Then we will give you an example of how other newsrooms and news agencies use already data for wildfires in their reporting. And then we will have a third part that specifically introduces you to 3 web visualization portals that help you to get access to satellite data for wildfires. And at the end, we will have also, you will have an opportunity to ask questions, and we will have a closure of the workshop. Good. Just a short introduction also about what ThriveGeo is. So we are a company that was founded last year, and our mission is to empower individuals and organizations to thrive with Earth observation data. We specifically do this through training. So we run workshops like this today. And in these trainings, we have also an integrated community, a community where Earth observation experts and Earth observation data users can meet and engage. And with this, I'd like to go to slido.com and enter the hashtag satellite, because then we will start our short icebreaker. So you can either scan this QR code, or you can go to slido.com and enter the hashtag satellite. And then you will get to a question, because we are interested in who is actually joining us today, and also where you are in your journey for satellite data or satellite data use, and also using satellite data for reporting. So we ask you on a scale from 1 to 5, from 1 not confident to 5 highly confident. How confident do you feel in using satellite data? Okay, so we see quite a spread. So we have some who feel quite confident, but then the majority so far is around 2, so not confident, but yeah. Okay. Good, Dan, thank you. And the second question is specifically for using satellite data in reporting. If you already thought about it, or you also tried to already do it, what challenges are true for you? And this is a multiple options question, so you can choose multiple options. So what is true for you? I don't know where to find the data. I don't know what data to use. Not having access to satellite data experts. Using satellite data and reporting is time consuming. Or lack of data analysis and visualization skills. Okay, so here we see at the moment a clear winner on, or not a winner, but I don't know where to find the data. So really data discovery is a challenge. But then also not having contact or access to satellite data experts, followed by using satellite data and reporting is time consuming. Okay, I just give another 10 seconds and then we can continue. Okay, but at the moment it looks like, yes, I don't know where to find the data. Okay, so hopefully this will be already a bit easier by the end of this workshop, because this is really where we focus on today. Good, and with this, I will hand over to my colleague Sabrina.
Thanks, Julia. So now I will provide you a really quick introduction to remote sensing in the next 5 minutes. So let's try and get you a sense of what this is. So remote sensing is made out of 2 words. There's remote and sensing. So the sensing part, it's about getting information about something. And that's how we use our senses, right? To get a sense of what's happening, to understand characteristics about the world we live in. And remote means from a distance. So we're getting information about the Earth from a distance. And how do we do this? We use radiation measurements, which are mounted on from instruments that are on satellites, on aircrafts, or on drones. Next slide, please. So as you can see on the left image here, the sun, when it shines on the Earth, it reflects light off, and a satellite with an instrument on top of it can then capture this information from this reflected radiation. And this is similar to how our eyes work, right? When you look at an object, what you see are light that's being reflected off the object into your eye. And then your brain can then make sense of this information, and then you see an image from this light. So the satellite does a similar thing, except that not only can it see like we do with the visible part of the light wavelengths, but it can also capture radiation information from other parts of the wavelength that we can't see. So an example is if you have like a hot cup of coffee or tea in front of you and you close your eyes, you can't see it anymore. But if you put your hand close to the cup, you can feel that it's hot, it's warm. So there's also this thermal radiation that can be emitted from the Earth and from your coffee cup that can then also be sensed by a satellite sensor, or in this case, your hand. So that's an example of other parts of wavelengths that we can also get information from. Then there's also active remote sensing using active sensors. So bats, right? They're flying around, they're blind, but they use sound to navigate in the environment by emitting these sounds, which then bounce off the objects back into their ears, and they can then navigate. So similarly, an active sensor will be shooting out, for example, laser beams at the Earth and measuring the time it takes for these lasers to bounce back, as an example. So this also is a way for active sensing. Then also they use other wavelengths as like microwaves, for example, for this type of sensing. So types of satellites, we have two main types. One is a polar orbiting satellite that goes around the poles, so north to south. And as the Earth rotates from west to east, you can see that the Earth is being scanned, so to speak, in strips as the Earth rotates and the satellite moves around. So it may take several days for the satellite to scan the same area again, which leads to a period of time where you need to wait before the next piece of information you can get for the same area comes in. These are also closer to the Earth, so you can actually get higher resolution, more sharp images of the Earth. Then the other type of satellite that you will find is a geostationary. So if you imagine an orange and you put a pin into the orange and you move the orange around, the pin's always stuck on the same side of this orange, right? So similarly, a geostationary satellite is always looking at the same disk or the same part of the Earth as it moves around and rotates in orbit together with the Earth. So what this means is it can scan within 5 to 15 minutes this entire area, and you can use this for animations of, say, smoke for wildfires. However, because they're located further away from the Earth, the images that they are capturing will be coarser or not so detailed as the polar orbiting satellites. Okay, next slide, please. So now there are 3 levels of data that you should be aware of, level 1 to 3. And basically, level 1 is the most minimally processed data, and level 3 are the most processed. So level 1 data refers to radiation information that's measured by the satellite that may be just minimally processed to remove noise, for example. And then level 2, these are the data that may already be giving you a specific piece of information about something, such as fire temperature or the amount of carbon dioxide in the air. And it's more heavily processed and also includes location information. And level 3 is usually level 2 data that has been summarized in some way and put into a regularly spaced grid. So as we saw those strips of the Earth being scanned, now you can imagine now that it's now in a nice map form where it's been summarized to, say, the areas of the Earth that have been burned in the month of January 2023. So this is the most processed level of data. And that's it. That's a really quick overview of remote sensing. Now I'm going to show you a few reporting examples for how different newsrooms and newspapers and programs have been using satellite data in their reporting on wildfires. So there are 3 fire life cycle stages that we should be aware of. There's before the fires, during active burning session, active burning of the fires, and then after the fires have occurred. And there are several questions that might come to you during each of these phases. So before the fires, you might be interested in how likely is it that a fire will occur? During the active burning phase, where are the fires? How hot are they burning? Is there smoke being produced? Are there emissions like nitrogen dioxide or some other gas that comes from the smoke? And where is it going? And then after the fires, how large of an area was burned? How badly was this area burned? And because fires take time to progress and burn over time, when did a particular area burn? So now we're going to start with the before fires stage. And here we have an example from the Canadian wildfires last year from CTV News, where they showed a fire danger forecast from Natural Resources Canada. So these fire danger forecasts are created using satellite data. And in this particular image, you can see blue represents low fire danger, whereas red represents extreme fire danger. And this also coincides with areas and provinces in Canada where later there were several fires occurring. And you can find this data usually either from a national source, in this case from Natural Resources Canada, or we also have some regional and global sources for this data. Next slide, please. So here the BBC News have a map showing the fire danger forecast for the Greek wildfires again last summer. And this was the fire forecast of 28th of July. And here they use the Copernicus Fire Weather Index, which we will introduce later on. And here you can see that green shows low fire danger, whereas the reddish colors like red for extreme danger and dark red or almost maroon for very extreme levels of fire danger can be seen in, say, Northern Africa and certain parts of Turkey and Greece. So now we move over to the during active fires phase. And here's an example from Network 18 showing agricultural fires in India. So in Punjab, Haryana, and Uttar Pradesh. And these red dots represent active fires or thermal anomalies, meaning areas that are unusually hot. This might come from other types of hot sources of heat, for example, volcanoes, but you can probably tell that most of these are farm fires based on where they're occurring. And the data that's used to create this map comes from NASA, particularly 3 satellites called Landsat, VIRS, and MODIS. Next slide, please. And in addition to active fires, we also have smoke impacts. So here's an example of black carbon that has been transported from Australia towards South America from the 2020 Australian fires, again covered by BBC. And this data comes from a climate and weather model that incorporates satellite data into this calculations. And once again, here's another image from the Greek fires from the BBC. And we're again using the fire hotspots and thermal anomalies. And this map shows you areas that were burning in the last 7 days in orange and active fires in the last 48 hours in red. So you can kind of see that areas where the fires are now in the last 48 hours, they're on the periphery in Rhodes Island of where the areas which were burning before. So it kind of shows you how the fire has been spreading over time. And here they added some labels, which are also useful when you want to show where important settlements or infrastructure are located. So here's another smoke impact using that same weather and climate model that I showed you earlier from the Australian fires, except now this is again from the Canadian fires covered by NPR. And in the actual image itself and on their website, they didn't include the color legend, which we included up here, this bar that shows you what each of the colors mean. So again, when you're reporting, you might choose to omit that information if the focus is just on showing how large this plume of smoke is and how it is traveling. So now after the fires, we can look at the impacts on where it was burned. So here we have 2 images from Kangaroo Island in Australia showing in December 2019 on the western part of Kangaroo Island, a verdant green forest. And this forest area, unfortunately, has now been burned in January 2020. We see that it's been only blackened areas left. And we still see some smoke, what appears to be smoke in the middle, which is another active fire possibly occurring. And this is a true color composite, which means that it's an image which has been created to look like what the human eyes see using the visible bands of light. And the data source for this is likely to be from Sentinel-2. Next slide, please. So in addition to the true color composite that I showed you before, there are also other parts of the light wavelengths, the electromagnetic spectrum, that we can use to highlight certain features. So if we use, for example, the shortwave infrared part of this light, of the light spectrum, we can actually use a special recipe to make an image that highlights the burn areas in red and healthy parts of vegetation in green. And this is exactly what this particular false color composite does. And again, it uses Sentinel-2 for this data from the Greek fires in 2023. All right, so now I'm going to hand this time over to Julia, who will tell you a bit more about some of those data that we saw being used in actual reporting examples and where you can find them. So thanks, Julia, over to you.
Thank you, Sabrina. Yes, so let's go right into getting an overview of some of the parameters that you can use for wildfire monitoring. So as Sabrina already said, along the wildfire life cycle, we have 3 stages. So before, during, and after. And during all these 3 phases, we have satellite data we can use to get more insights what is actually happening. So on the first phase before fire, we look for fire risk. So we have data, as Sabrina also showed in the reporting examples, that give us the potential fire danger or fire risk for the next days or the last 48 hours. Yes. And then during a wildfire, we can focus on specific aspects of a fire. So where the fire is happening, then we really look for fire hotspots, and a parameter from satellites is called fire radiative power, which really shows us the intensity of the wildfires and also where they really located. But from fires, also smoke is emitted, and this smoke also is observed by satellite, and we can also monitor this because the smoke is usually then also transported by larger weather patterns, and the smoke comes with a set of emissions which then impact often the air quality levels in cities and specific regions. And so we can monitor the smoke, we can also see how the smoke is transported, and then in these areas where the smoke is transported, usually we can then also see a drop in air quality or an elevated level of specific emissions and trace gases. And then after a fire life cycle, we can really assess the area that has been affected. And as Sabrina already also showed in some of the examples, there are specific satellite composites that help us to highlight the burned area in a specific color and to make this really obvious. So just as a note as well, you will get after our workshop, you will get an email where you get also today's slide. This is again here a very detailed table on what parameters you can use from satellites and also what they are. I will not go in detail on this now, and will directly start with introducing you to 3 web visualization portals. So the first portal I'd like to highlight is the European Forest Fires Information System. The abbreviation is called EFIS. And EFIS is part of the Copernicus Emergency Management Service. And this gives you data for all the 3 fire life cycles. So before a fire, it gives you information on the fire danger forecast. So it uses data from ECMWF to assess and give you information on the fire danger. Then during a fire, it uses data from NASA, from MODIS and WIRS. These are 2 satellites, and specifically highlighting fire hotspots. And then after fire, it also uses data from MODIS and WIRS to identify and show you a burned area and areas that are affected. However, EFIS, compared to the two other portals that we will introduce you, has limited capabilities in giving you an option, for example, to download or to retrieve the data as a map and as an image. So that's why I will only focus in EFIS how you can visualize fire danger forecast, because this is the only portal where that makes this information available, whereas all the other data sets are also available in the two other portals we will introduce you to. Good. So I'll just go to the portal here. So don't worry, in the slides you will also get the direct links to all of the portals. And I will just give you a quick overview on how you can navigate through the portal and get the data you're interested in. So as I said, on EFIS, the specific focus is here that it gives you an information on the fire danger forecast. And it is quite easy to navigate. So here you have the current, they call it current situation viewer. You can here just tick the fire danger forecast, and then you will get directly for today the fire danger forecast on a global level, and you can zoom in and zoom out. You can also, and so here you can also specify the source. So they make the information available from two different models, from ECMWF and Météo France, which is the French National Meteorological Organization. And there's also a set of indices, but the most common one used for assessing the fire danger is the fire weather index, which Sabrina also said or showed you already is mapping the fire or the fire danger in 5 different classes, from here in 6 different classes, sorry, from low danger to very extreme danger. So the more red and purple the pixel or the information is, the higher the danger. So but you can also assess like the fire danger from a past event. So let's say, for example, last year we had in Canada in June, the Canadian wildfires were quite intense. So you can assess and also monitor the wildfire risk on specific days or also specific past days. So this is a visualization of where you get an assessment of the fire risk and the fire danger. However, there is, like, as I said, not an option that you can download the image. So if you would like to use this information, then you would need to do a screenshot from the portal here. But this is one portal where you can get access to this data in an easy, visualized way. Good. Then I will go back to the slides, and also just for your info, for each of the data sets we introduced, we also developed a kind of data fact sheet that gives you more information on what a parameter specifically is, the temporal and the spatial resolution, and also where the data comes from, and also the access portal. As said already, the data access can vary, and depending on what you want to do with the data, you can then also get direct access to download the data. But this is not a focus of today's workshop. So that's why we only focused on giving you a link where you can access the data in a visualized way. Good. So then the next portal I'd like to introduce you to is FIRMS. FIRMS is the abbreviation for Forest Information for Resource Management System, and this is a system that is developed by NASA, and this is specifically aims to give you information during a fire. So it gives you information on fire hotspots, so where are potential fires located, and this information is given by 3 different satellites that all have three different resolutions. So, and is a combination of these 3 satellites really give you quite an detailed information on any potential fires that are observed. And then to also assess the smoke that is coming or that is emitted from wildfires, FIRMS gives you information or gives you a visualization option to visualize RGB composites from 2 satellites, from MODIS and VIRS. And together, to have the level or to have the true color composites and the fire hotspots, they give you a good impression and a good picture on what is happening at the moment. Sorry, and I will go now to FIRMS. So when you start the web portal of FIRMS, this is how it looks like. So you get the current fires of globally that are detected by the 3 satellites that are called Landsat, VIRS, and MODIS, or like the instruments. And so basically, you can hear, so this is like the last 24 hours. You can also choose a specific time again. So if we, for example, go back to our example from Canada in June on, let's say, the 28th of June, and we zoom into Canada, then we see here for specifically Quebec had like quite some fire hotspots, and you can then additionally also add a true color composite from either MODIS or VIRS. And this is where you also already see some of the limitations of some of the satellites, because some of the satellites, they can't go or look through clouds, and this can be often quite a limiting factor for getting right images, that because we have clouds, and so we actually don't know what is happening beneath the clouds. But for the 28th of June, at least on this area here where fires were identified, we also see here smoke coming from the fires, and we were lucky because there were no clouds for this region. Yeah, and you can then also capture. So you can here, if you go to capture, then you can also download a screenshot of your current map view. You can include a header, a timestamp, a scale bar, and then you can download it as a JPEG or a PNG in an image format, or even as a GeoTIFF if you want to then analyze or process the data further. So yeah, so this is the second system we would like to introduce you to. This specifically focus on giving you access to data mainly from NASA, and then also mainly giving you a picture of what is currently happening. So during a wildfire. Good. When we now go back to our slides, then again, we have here also a data fact sheet that gives you more information on the specific data FIRMS offers. So FIRMS offers, as I said, for fire radiative power, like for the fire hotspots, 3 different satellites with 3 different resolutions. And these 3 different resolutions, they really allow you to capture all the potential fire hotspots that are observed. So like specifically the inclusion of Landsat fire hotspot information captures additional fires that would be overseen by a coarser resolution satellite, which is MODIS, which has a resolution of 1 kilometer. And then the smoke detection, we have 2 different information from also MODIS and VIRS. They give the similar or the same information. So we have a true color composite or true color image that highlights a specific feature. So in this case, smoke coming from wildfires. Good. And then the third data portal I'd like to introduce you today is the Copernicus Dataspace browser. So this is a visualization portal specifically for Copernicus data. And from Copernicus, there are a set of satellites that can be used specifically to monitor what is happening during a fire and also after a fire. So during a fire, to get smoke information or smoke emissions, we can use the satellite called Sentinel-3, because Sentinel-3, the OLCI instrument, helps us to get information on smoke via true color or false color images. And what specifically also the Copernicus Dataspace browser allows us, and the Copernicus program gives us information on it, is to track aerosols and trace gases. So also what trace gases and aerosols are emitted through the wildfires. And there is the Sentinel mission Sentinel called Sentinel-5P, and this gives us specifically information, for example, on nitrogen dioxide or carbon monoxide, or also aerosol index, that are all good information that help us to assess the air quality situation together with wildfires. And then after a fire, in order to assess the burned area, you can use from Copernicus the Sentinel-2 satellite, and specifically also here a false color composite allows us to really assess the burned areas. And so now let me go to the third portal and the Copernicus data browser. So this is how it looks like when you start the Copernicus browser. So you have here, you can choose different data or you can choose data collections. And then you can also here choose a specific date. So let's say we're interested in let's say we first start with Sentinel-3, so we want to monitor the specific smoke that was emitted through wildfires. So then we can go to Sentinel-3. There are two different instruments, so a satellite can have multiple instruments or can carry multiple instruments. But specifically for the smoke monitoring of wildfires, you can use the Sentinel-3 OLCI instrument. And so if we select this, and then we select again here also from 2023, our favorite, or not favorite, but our example from Canada last year. So unfortunately, they were quite severe. And we choose June. Let's do, for example, the 20th of June. And then you see already that the portal gives you a set of different composite options. So true color is always what we see, how we see the real world. And then, as Sabrina already said, then there's a set of false color, and false color just gives us options to assess a specific feature in a more prominent color, so that it helps us to highlight a specific feature. So if we now zoom in, then we get information. So let's, let's just go to Canada, where we want to go. Just zoom out again. And then we can zoom in. Oh, network. Okay, now it's going. Okay, so yeah, and so for this area, we see here already smoke emitted from specific wildfires. So this is now 20th of June. I can also choose the 28th of June, and And we see here also more quite clearly smoke emitted from wildfires. We can then also choose like a false color composite. And so now we see like the general vegetation here in red, but then also the false colors or like the smoke is now in light brownish. So this is just another option to specifically highlight different features. And with Sentinel-3 ALGI data, you can also use the false color composite to highlight smoke in light gray, in light brown. Good. So then let's now choose, as I also said, from Copernicus, we can also get Sentinel satellite data that allow us to assess the air emissions that or trace gases that were emitted. So we can, for example, load nitrogen dioxide. We can again go back to our selection of the date, and we can zoom out a bit. And as you see already, Sentinel-5P, we also are impacted again by clouds and also the data quality for some aspects. But so the data that is available, if we zoom out, we see already here that, for example, here over New York, that we have an increased level of nitrogen dioxide for the 28th of July. And this shows already that often you don't see directly elevated levels of trace gases or emissions directly where the wildfires occur, but you see then that the smoke and the aerosols, they transported quite fast distances often, and then you see other regions impacted where you then see increased levels of specific trace gases. So here the example is that we can see elevated levels of nitrogen dioxide over New York. And then the other example, if we now go to what is happening after the fire, so if we want to see the affected area from wildfires, we can now choose the Sentinel-2 information and specifically level 2 data. And then we can choose, for example, here, an example was in September the 21st. And here again, it gives you different options on true and false color composites. And so if we want to, if I zoom in here again in our area where wildfires happened in Quebec, then takes a bit, could be also, okay. So we see here already in true color some brownish patches. There is a specific combination which is called SWIR, which stands for shortwave infrared, and this highlights specifically burned areas more prominent. And so we see here quite a few dark red, brownish patches here, which all indicate affected area by wildfires in Canada in September last year. So if you, let's say you want to use one of these examples in your reporting or in one of the articles, then you can here, so the Copernicus browser allows you also to download your current map view. You go here to this icon, and then you can also specify if you want to have specific map overlays, if you want to have a legend, if you want to crop to a specific area of interest. You can also give it a description, and then you can download it either as JPEG or as PNG. So so this is the option here to get information on your current map view and also the data you selected. Okay, so this was a quick introduction to 3 different data portals and also an introduction to quite a few data sets that can be used and that are available for wildfire reporting. Here again, we also put together the different information on the satellite data from Copernicus and specifically available through the Copernicus data space browser. So for smoke detection, we can use Sentinel-3 ALGI data, and here a true or false color composite. For emissions, we can use data from Sentinel-5P, either carbon monoxide or nitrogen dioxide or ultraviolet aerosol index. And from burned area, we can use information, a composite information from Sentinel-2 satellite. And yeah, with this, I'll hand over to Sabrina again.
Thanks, Julia. So that was a great overview of different types of data that is available for monitoring fire and that you can use to also report. So we just wanted to highlight that all parts of the wildfire life cycle, you can use satellite data to report about. And it also helps you to highlight and visualize certain aspects of wildfires that might be difficult to see from just a photograph because of the large transnational, transboundary impacts from smoke or emissions, for example. To see how big that smoke plume is can be quite breathtaking and will add important context for any story about that. And in addition, we showed you 3 different portals or websites where you can go and access data that's already been visualized, and you can export it in a form that you can just add some labels and get it ready for your article. So those are the 3 key points we hope that you can take away from this workshop. Next slide, please. So as Julia mentioned, we have the links here for all those browsers in the slides, which we will share with you. And we have seen that there was a new report recently released on Europe's wildfire crisis. So we welcome you to take a look on that as well as we advance into summer, where unfortunately there will probably also be outbreaks of wildfires. And if you're curious about commercial satellite data, both Planet and Maxar have news and media programs that you can also find links to here. And we have prepared a workshop handout, which we will share with you, that covers a lot of this data in more detail as well. So if you found our 1-hour workshop helpful and you want to dive into more practice and actually get your hands on some of this data and understand also the nuances between picking between different data sets, we encourage you to send us an email at contact@thrivegeo.com. We're putting together a 1-day workshop on satellite data for journalists, not just focusing on wildfires, but also broadly on different topics. So we welcome you to join us for this 1-day workshop. And we also include, once again, real-life reporting examples, and the data that they used will give you a more in-depth look at what remote sensing is and what you can do with satellite data, what are some do's and don'ts, and most importantly, that practice where we will actually be working with the data, either with browsers or with desktop software like QGIS, for those who have a bit more skills with GIS software. So once again, please contact us. We also offer some networking opportunities during lunch and an online community where you can stay in touch and contact each other for the next 90 days and also have access to other satellite data experts.